Step 2. Grignard reagent preparation and addition of the Grignard reagent to fructone, period 4 and part of period 5. Before coming to lab, record and or calculate the amounts of all reactants you'll be using in this period: magnesium, bromobenzene, ether, and your ketal. Measure about 3.6 or 3.8 grams of magnesium turnings. Do not exceed 4 grams. Grind them in a mortar for 5 to 7 minutes. The purpose of the grinding is to get rid of the magnesium oxide, which is formed on the surface, and exposes fresh magnesium surface. Transfer the turnings to a 3-neck 500 milliliter round bottom flask. Lightly grease all joints. After assembling the setup, place 2 drying tubes filled with drying agent. It must be white or blue. Purple color of the agent indicates moisture presence. Measure 90 milliliters of ether and 15.7 milliliters of bromobenzene in a separated graduated cylinder for the next step. Add about 5 milliliters of bromobenzene through the side neck of the flask. Put the rest of it, along with about 60 milliliters of ether, to the addition funnel. Close the funnel with a stopper, take out and swirl. Then swirl the entire setup. Put the funnel back. Here are a few tips on how to start the formation of Grignard reagent if the first attempt failed. 1. Warm up the round bottom flask with your palms or in a warm water bath. Use just tap water. 2. Try seeding. Use a few drops from your classmate's reaction mixture. 3. Add a small crystal of iodine to your reaction mixture. Swirl and warm the flask. Pour remaining 10 milliliters of ether down the condenser. Adjust the rate of addition of bromobenzene solution, so it will take 15 to 30 minutes to add the entire amount, about a drop per second. Keep in mind that formation of Grignard reagent is an exothermic reaction. If the addition of bromobenzene happens too fast, you might boil over your reaction mixture. As a good practice, add bromobenzene slowly and keep ice water bath at hand. If the cooling slows down the reaction, you can warm it in a warm water bath. Grayish, olive, or tan to brown coloration of the solution is a good indication of a reaction progress. Let it reflux gently until most of the magnesium is dissolved. While you wait, prepare for the next step. Measure the needed volume of the fructone, the ketal from step 1. Cool the reaction flask down in the ice bath. Measure 1.2 milliliters of fruit tone. Pour to the same addition funnel. Do not rinse it after the previous step. And add 50 milliliters of ether. Swirl the flask to mix it and slowly start the addition. Keep the round bottom flask in the ice bath. Swirl the flask periodically to ensure proper mixing of the reactants. When all the solution is added, remove from the ice bath and stir with a glass rod periodically for 15 minutes. Carefully add 100 milliliters of ammonium chloride. Slowly at first, dropwise, then start pouring by small portions. Ammonium chloride serves as a source of protons here, and it protonates the anionic intermediate. At this moment, you will see two layers in the flask, aqueous at the bottom and organic at the top. Decant the ether layer to a 250 ml Erlenmeyer flask labeled ORG. Add 50 ml of fresh ether to the RB. Swirl vigorously and decant the ORG flask. It is advisable to wash the organic layer with water and dry it over magnesium sulfate in the same lab period. If you are running out of time, you can stop after decanting the second ether layer to the ORG flask. Transfer ORG to a separatory funnel. Add 30 milliliters of DI water. Shake then drain water. Pour ORG layer through the neck of the funnel to a new Erlenmeyer flask. Put enough of the drying agent to cover the bottom. Cork the flask. You can leave it for a week until the next period.